Hi, I'm Tom Nahomi from Dell EMC. In this demonstration video, I'll be showing the new features of the Dell EMC PowerFlex CSI driver 1.4. As part of this release, we've updated the CSI protocol to version 1.2 and added support for Kubernetes 1.20, OpenShift 4.7 with both RHEL and CoreOS worker nodes, as well as support for RHEL 8 and CentOS 8. The PowerFlex CSI driver version 1.4 adds support for managing multiple PowerFlex arrays from a single driver instance. In addition, we've added support for ephemeral inline volumes and added support for multi-mount volumes. As you can see, I have an OpenShift cluster running version 4.6. The new PowerFlex CSI driver is already installed on the cluster and connected to two PowerFlex systems using the multi-array CSI feature. PowerFlex CSI driver version 1.4 adds support for managing multiple PowerFlex arrays from a single driver instance, allowing the Kubernetes cluster to consume storage from more than one PowerFlex system. This feature is enabled by default and integrated to even a single instance installation. To manage multiple arrays, you need to create the array connection configuration that lists multiple arrays. For the purpose of this demo, I created 4 storage classes. The first 2 are set to create volumes from the first PowerFlex system, each one from a different storage pool. The second storage class are set to create volumes from the second PowerFlex system. One formats the file system with ext4 and the other one with XFS. Next, we have a stateful set of a single pod with 3 persistent volume claims, one from each storage class. I'm creating it using the kubectl create command and waiting for OpenShift and the CSI driver to process the requests. Within a few seconds, we can see that the pod is up and running. By navigating to the PVC tab, we can see that the volumes have been mapped and created from the different storage classes and PowerFlex systems, according to the storage class configuration. We can open a terminal to the container to make sure that they are all mounted and accessible. By navigating to the PowerFlex UI, we can see that the 2 first volumes have been created on the first PowerFlex system, while the third volume is on the second system. Starting from version 1.4, PowerFlex CSI driver supports ephemeral volume workloads. Inline ephemeral volumes allow you to define a pod spec that creates inline ephemeral volumes when the pod is deployed and deletes them automatically when the pod is destroyed. This feature allows you to specify CSL volumes directly in the pod specification rather than in a persistent volume object. The most common use cases are jobs and reports. As you can see, I specified the volumes definition inside the pod YAML and set the driver to our PowerFlex CSI driver. By running the kubectl create pod command, we can see that in addition to the pod creation, 2 new volumes have been created. If we navigate to the PowerFlex UI, we can see that 2 new ephemeral volumes has been created and mapped to the OpenShift worker nodes. These volumes will automatically be deleted once the pod finishes its lifecycle or destroyed. The next feature is multi-mount volume. This feature allows us to mount the same persistent volume on multiple containers in the same pod. As you can see in this example, I have 2 containers in my pod spec. Each and every one of them has a mount path to the same volumes. I'm creating the pod using the kubectl create command and waiting. By navigating to the PVC tab in OpenShift, we can see that the 4 persistent volumes have been created. On PowerFlex UI, we can see the volumes, each 2 in each PowerFlex systems according to the pod spec. Now, I'm opening a terminal on the first container and creating a file on one of the persistent volumes. As you can see, if I navigate to the second container in the pod, I can access the file and modify it. I really hope you find this demo useful, and thank you very much for watching.